Hello. So today I'm going to do an introduction to the OpenMined project. This talk has been repurposed from Andrew Trask, which originally developed these slides. I am now acting as an evangelist and an open source developer for the project. My name is David Rodas. So quickly jumping in, what is the traditional AI business model? So today you acquire data about people, train a model that does something useful, and then you sell that model back to the individuals in the form of an application. So what are problems with this today? So there are many problems, such as privacy. People are losing control of their data, where they risk embarrassment, resale, persuasion, or blackmail. They're losing a natural income, so data is now viewed as a natural resource, just like oil. Sensitive product problem. So some of these services are quite invasive or creepy. For example, I've seen a service that has started up recently which would take the pictures of individuals using social media or wherever they can find the information and evaluate the facial biometrics, performing some bias to determine if that individual would be a suitable hire for a company. And this company is working with various HR organizations. Aggregated power. So there are a few companies in the world that may jump out at your mind that have a lot of data, and this puts small startups at a disadvantage. So success criteria for this open source project: privacy. People get to maintain control of their data. Income. People can earn a passive income from their data. Sensitive products are still possible to be built, but they are built safely. So decentralized power, everyone controls the data, and this is still going to be a productizable ecosphere. So the creation of products and services will still be possible. So quickly, we're going to run through the ingredients for a solution, and then step 2, we will apply these ingredients for a successful application. So the first part we will run through very quickly and just touching on a few topics: deep learning, federated learning, homomorphic encryption, and blockchain smart contracts. So some of you may be familiar with some or all of these topics, but I want to touch on them very quickly. Deep learning, how does it work? And a couple of deep learning libraries that you can go and reference. So deep learning, you're basically converting dataset A to dataset B. So there's a hierarchy, aka neural networks. This is where the form deep comes from, all of these layers that are interconnected to each other. How does deep learning work? So basically you initialize a random function, the output is given, you compare that output. Is the prediction correct? Is it not? And you tweak these functions. So each of these lines will represent a so-called gradient, and these numbers will be tweaked plus or minus a very small value. So for example, we may process the picture of a puppy and get the outcome of cat. So a cat is not the same as a dog. So we will tweak these gradients in a deep learning process so that at the end, when we pass a picture of a dog through, we are returned the label of a dog. Very simplistic overview of deep learning. Deep learning libraries, if you want to jump in: PyTorch, TensorFlow, some of my favorites. Federated learning. What is federated learning and how does it work? And some federated learning platforms that are available today. So typically, I would think of federated learning in the aspect today, which is the most easy to conceive, is the text prediction that you will use either on your Android or Apple phone today. So as you are typing in, the device will now start to recommend what is going to be the next word in your sentence. So this machine learning is done over a distributed data set and that is where the mobile phones will come into play. So how does federated learning work? So the users download a neural network model that we just looked at with the gradients. The users train the model on their own data. The users upload these gradients that are representing the training data to a server in the cloud. These gradients are summed together to try to protect the user's privacy. The model is trained and updated in the cloud, and then the user will download the model that has been trained again, and that will enable even more advanced text prediction in this particular scenario. And this scenario can be applied to many different applications, games, photo recognitions, etc. So the two federated learning platforms today that are primarily in use is based on the research done at Apple and the research done at Google. Unfortunately, today there are no open source federated learning platforms in use that I am aware of. Homomorphic encryption, and how does it work? So this is a very new topic to me and most of the individuals I've presented this topic to. So homomorphic encryption. Basically what this is going to do is allow the encryption of a numeric value and allow us to perform numeric operations on top of this encrypted value. So example, we may run 3 through this homomorphic encryptor and we will return cipher A. We'll run 5 through this and we will return cipher B. So what homomorphic encryption enables us is to do 2 times cipher A, and we will get 6 cipher A plus cipher B. We can get return A, which is 5 plus A. So this is a very basic example, and you can imagine, yes, I could reverse engineer these cipher values, but if you step back and you look at the deep learning with the hundreds of gradients or thousands of gradient values in there, reverse engineering that becomes a very daunting and possibly unachievable task. So deep learning with homomorphic encryption, you can jump out and check out many open source libraries, and if you Google homomorphic encryption, you will come up with a plethora of research around this topic, which is very interesting, and I encourage everyone to jump out and take some time and study this. Smart contracts. What is a smart contract? What is a blockchain? How does the blockchain work? And how do smart contracts work? So what is a smart contract? So I like to think of a smart contract as an interpreted program that lives on top of a blockchain. So this data is stored on the blockchain, and it can process many things. It can act as a ledger, grabbing event and statistics, the status of today's events, for example. And it also, inside of this interpreted program, the smart contract, lives the rules for updating the change of the state of these variables. So what is a blockchain? A blockchain is a large distributed data set. And it's very interesting. So no one can edit or delete an old entry. No one can fake a new entry. And this is enforced by the fundamental computation limits, aka proof of work or mining, as you may understand with Bitcoin and so forth out there today. So how do blockchains work? I encourage you to take a moment and jump over to this URL and mess around. This is a very interesting web page that will show you some of the mathematical operations on how the empirical data is enforced on a blockchain. So how do smart contracts work? So the smart contract data, again, lives on top of the blockchain, which the blockchain cannot be modified. It can only be updated. So essentially, these interpreted programs can be updated, and the updates are available for everyone to see living on the blockchain. So there's complete transparency in this process. So we have very quickly went through the ingredients for a solution. Now we will apply these ingredients for an application. So again, the pieces that we will be using are deep learning, federated learning, homomorphic encryption, and blockchain with smart contracts. Again, we want to surmise the current status of the industry, the AI business model typically in place today, acquire data about people, train a model that does something useful, and then sell that model back to the individuals in the form of an application. Again, problems. People are losing control of their privacy, losing control of their data. No one is earning a natural income for the data that they are sharing. Data is a natural resource. True, some people may want to be a data donor, but the amount of data being shared is at a phenomenal rate today by individuals, and it should be returned in the form of an income. And then there's also a very sensitive product problem that needs to be addressed. So the ingredients, we have just went through these: federated learning, deep learning, homomorphic encryption, and blockchains and smart contracts. So now we will jump into the architecture proposal from Andrew Trask. So here's a cloud-based model of what we would simulate today. All of the training is done inside of the cloud for AI Inc. All of the user's data lives inside the cloud. So this is the architecture we are going to try to break apart. So recipe one, so we're going to apply deep learning with federated learning. So inside of AI Inc.'s cloud, they will initialize a model. The initialized model will be sent down to Joe. Joe will receive this and train the model. The model will be uploaded to AI Inc., and this will be the gradients, so the tweaked values inside of this neural network. The model gets a little bit smarter. This will be done with Jane's data, and as you can see, the model continues to evolve and become smarter. This will be done with Jack's data, and now all of a sudden we have a very smart model that AI Inc. has in its possession, and this is based on the data that has been donated at this point to AI Inc. So what are the pros? So this model is a very nice step forward. People get to keep their data secret. There is privacy in this model. What are the cons? So unfortunately, the gradients can give hints about the data. People can also steal these models back here. So if you think about an application that is going to detect cancer, so at the end, this model may be trained and downloaded to an individual's phone. That individual could then take that model, which may be worth $1 million+ and start their own application. This again is also a blind marketplace, so no one is getting any income for the data that they're being shared. And then sensitive products can still be developed, so none of this has been addressed at this point. So let's move forward and add homomorphic encryption to this workflow. So with homomorphic encryption, we will step through the same workflow: deep learning, federated learning, and homomorphic encryption. This time, the model initialized inside of the cloud will be wrapped in homomorphic encryption. This initialized model will be sent down to Joe. Joe now cannot see what the model is doing because it is wrapped in homomorphic encryption. But Joe can train the model, and the training process works the same way as before, except that the model is passed back and forth in an encrypted fashion. So we'll rinse and repeat this cycle, and the model comes out very smart again at the end. The model can be decrypted by AI Inc. and studied, and the process can continually evolve. So this is great, right? So people get to keep their data secret. Now people cannot steal the encrypted models, and profitable businesses are being built based on those valuable models being created. So what are the cons with this model? So AI Inc. can steal data without being discovered via homomorphic encryption. So unfortunately, a malicious company could modify the neural network model to basically just siphon all of the data and not actually perform deep learning. And because the model is encrypted, no one actually knows what's going on here. And then still, this is a blind marketplace. So there's no competition on price, and there's no natural income being generated. Next, we want to evolve this workflow by adding another ingredient in, smart contracts. So you can see the workflow is slightly different now. So the model will be now initialized at AI Inc. And we have a nice data scientist, perhaps AI Inc. is a startup or a major corporation at this point. The data scientist will initialize this model using some of the OpenMined open source projects. So the model specification will now be sent to a smart contract living on a blockchain with a little bit of cryptocurrency. So this is just the model specification. There are no actual weights at this point. This model is now written to the smart contract on the blockchain. Random weights are initialized. The model is now homomorphically encrypted. Joe requests a description of the models available. Model specification is sent down. It's verified to be compatible. Request the model parameters now. The model is now sent down. Again, homomorphically encrypted. Joe receives this model and trains the model. The trained model is pushed back up to the smart contract on the blockchain. The gradients are verified as good. Now Joe is rewarded with a little bit of cryptocurrency for his work. What a beautiful model that we have now in place. So the pros again, people's data is kept secret. People cannot steal the encrypted model. This is a profitable business. Valuable models are being created. AI Inc. cannot maliciously steal data because we have transparency via the blockchain. And now we have an open market. Rewards are transparent. Oh no, so we have cons here. So the public-private key generation. Who is going to hold the private key for the homomorphic system? Because anyone that holds that can decrypt the model and the trained data. So the blockchain is not a good place to store this because it's 100% transparent. The miners could steal the model, so that is not a good place. And AI Inc., well, they could learn about data from the gradients. This is basically back to where we are today. So now we're going to introduce a third-party Oracle service. So we have the same workflow here with a couple of small changes. So on the data scientist side, everything will work the same, except he will also pass in his RSA public key this time. And then we have a third-party Oracle capsule service here. So this Oracle capsule service, the thought is today that this will be a black box service, perhaps run by large cloud providers such as Google Cloud or Amazon AWS. These Oracle capsule services will need to be very secure, and it would be recommended that the companies running these Oracle capsule services reach out and purchase stop-loss reinsurance contracts in the event of a data breach. So contracts starting at something like $1 million plus, depending on the value of the data flowing through these Oracle capsules in the event that there is a data breach. So let's step through this workflow now. So same thing, model specifications are sent over to the smart contract with a little bit of cryptocurrency and now the RSA public key. So these three items are now written to the smart contract. And now they are pushed over to the Oracle capsule. So the Oracle capsule has the model specification and the AI Inc.'s public key. Oracle now generates the public and private homomorphic encryption key. It generates the initialized parameters for the model. And now the black box Oracle service will encrypt the model using the homomorphic keys that it has now generated. This model will now be pushed back up to the smart contract along with the homomorphic public key. This will now sit on the smart contract in an encrypted state. So now we will cycle through the training piece again. Joe will call requesting model specifications. Model specifications are now sent down to Joe, viewed as compatible. Now Joe will request the model, most likely via interplanetary file system. The encrypted model with the randomly initialized parameters will be sent down to Joe. Joe will train this encrypted model, and again push this trained encrypted model back up to the smart contract on the blockchain. The gradients will now be verified as good. Cryptocurrency will be shared with Joe as he has generated good gradients for this model. So now we have this trained model living on the smart contract. So now this will be pushed over to the Oracle capsule service. The Oracle will be able to decrypt this because it is holding the homomorphic private key. Now the model will be encrypted with the data scientist RSA public key. This model will now be written back up to the smart contract and pushed over to the data scientist. So now the data scientist, having had generated the RSA public and private key, is able to decrypt this. So how can you jump in today? So OpenMined is an open source project. You can join our Slack channel, you can join our mailing list, and you can also view all of this on GitHub today. We are in a pre-alpha state. So here are the components today that have been created. We have Swift, a homomorphically encrypted deep learning library. We have Sonar, federated learning server. We have Mine, the federated learning client. And we have the capsule service that has been built. So you can jump over to openmined.org. Openmined.org generated this presentation based off of Andrew Trask's original talk. Here's my information, and here's Andrew's. And thank you for your time today.